All right, folks, welcome to week 10. Um, Finish line is coming up. There's only 4 more weeks after this. Um, yeah, no, whew, you know, the end of the semester always comes surprisingly quick for people because it feels like the first half is just dragging, and then the second half is like you're running around with your ass on fire. So you know, so today's topic is both straightforward and not, depending on how your brain works. The topic of the day is subqueries. Um, so last week we talked about joins and how we could pull data from multiple sources at once. Subqueries is similar, but it's not the same thing. A subquery is a nested query. So when you create a subquery, it will run, you'll have a query inside a set of parentheses. It'll run that query and return the results to the other one. So you know what you do when you do math and you have parentheses in your equation and you have to solve the parentheses first, and then the results of that gets passed out to the next layer of whatever the equation is? Same idea. Um, so there is multiple ways and multiple places you can use subqueries. There's some pretty fancy ways of using them, and I'm going to try to cover as many of them today as I can. The first and most common use for a subquery is in the where clause as part of the in statement. So if you remember before the break, we talked about the in clause in the predicates, where you can say in this list and it's a comma delimited list of values. It works great if you know what those values are, but if you don't know what those values are, but you are able to extract them using a query, why would you take the results of a query, copy them to Notepad, fix it so it'll work, and then pass it back in? The people who created the SQL language actually said, well, maybe somebody actually wants to not have to do that. So you got to take into account that when SQL was created, people were working on like green screen dumb terminals where there was no Notepad. So it wasn't straightforward. So let's say I want to go select star from airports, where country ID in. Well, I noticed today while I was working, my typing really sucks today, so this might be a struggle. Um, so what these queries are going to do is it's going to return a list of all the countries that start with C. That's the first thing it's going to execute. So it's going to do this. And it's returning the IDs. So we have 22 countries that start with, the letter C. And fine if you actually knew what these IDs were, but off the top of your head, you may not know what these IDs are. Therefore, what you do is you actually embed it as a subquery. So it returns the results of this query, basically this list of IDs here, and it passes it to the outer query now, so that instead of saying country ID, so this would be the equivalent of onwards and onwards until we get to the last one, all 22. I'm not typing 20, all 22. Obviously, you notice I stopped typing the ones I couldn't see on the screen. Once I couldn't see them anymore on the screen, that's where I stopped. So this gets transformed into this, and then it executes the outer query. So if I do this, we should get the airports for any country that starts with C. So an airport, Buenos Aires. We should have eventually in here. We'll get to some Canadian ones. Apparently that's Cambodia. 22 countries. There's a lot to go through before we get to the Canadian ones. apparently. Somewhere in here, we're going to hit some Canadian ones. Actually, how many came back? More than 500. So, let's change this to any country that starts with CA. Okay, let's make this list a little shorter. Okay, oh, there we go. There's Canada. Yeah, these are all Canada. Actually, I don't know how many countries start with the letter CA. Let's. Um, so there's only 5 countries that start with CA, and apparently Canada comes up first in the list. So this is a nice way of doing this without having to worry about what the IDs are, because sometimes you don't know what the IDs are. So therefore, why go through extra steps? So that's the most common use of the subquery is like this. Yes, we could have done this as a join. And I'll be honest, when I finished college, I was way more comfortable with subqueries than I was with joins. Because back then we didn't have the nice join syntax you guys have now. We had this weird crap that Oracle decided to create. And this was a lot easier for me to do what I was trying to do. Is there a performance difference? Small data sets, no. Larger data sets, there may be some performance differences. Sometimes the subquery will be faster. Sometimes it'll be slower depending on how you write it. So you have to experiment. Now, this is returning a list of values, like multiple values. You can also do subqueries that do a single value. From airports where let's do a really interesting one. Go see if this actually works. All right, so I just asked it, hey, can you give me all the airports where the elevation is less than the average elevation in the airports table? This is an example of being able to use an aggregate to filter. Remember when we were talking about aggregates and saying you can't aggregate an aggregate? This is one way of, or you can't use an aggregate in the where clause to filter your results. This is how you use an aggregate in the where clause. Because you couldn't even do the average. Actually, you could probably with the having. You probably could do it. So this is an alternate to using having. You can get really fancy with it. There's a few different things you can do with it. That's a single value. Now you can also go. And that returns a single value. So essentially, I don't know what the country ID is for Canada, therefore I'm going to select it. It'll return one value to the outer query. Now, you have to be careful with these, what they call the single value ones, because if you happen to try to do, let me just grab this again so you can see the error. I'm going to generate an error now. This gives us an error. It says subquery returns more than one row. That's because I'm saying, give me a list of airports where the country ID is equal to this. And when you say equal, you can only ever compare two values, right? You can't say is 2 equal to 5, 9, 8, and 3. That's essentially what I just tried to do. You can, if you're going to do a comparison operator or a less than or greater than or a not, that's another one you could do, a not equal. The subquery has to return a single value. So you just have to be careful. It's good to see the error message. When it says it's returning more than one row, that means that it's trying to match on one single value and your subquery is wrong. I'm going to put a comment on how this We're gonna. Okay, so this is the basic use of a subquery. There are a few fancier ways, and the next one is a magic operator called any. And you'll notice that I'm actually going to actually just kept my example from before, because every time I try to do this, I always screw it up. So I figured, you know what, I'll just keep my queries from before and just explain them. All right, so this is grabbing everything from countries where the ID is equal to any. Now this reads a little strange, but essentially it's saying, give me the countries where the ID is equal to any of these. Essentially, it's the same thing as an in. It's just modifying how the equal behaves. So it's saying it's equal to any of these. Personally, I just write it as an in because straight and much more obvious. But some people decided this was a good way to do it. So if we go select star of countries where the elevation is less than or equal to 0, and yes, there are countries where the airport is below sea level. So, when you talk about elevation 0, that's sea level. There are countries where the airport is below. And some of these countries include Cambodia, Cyprus, Jamaica, the Netherlands, because we all know the Netherlands are just one bad storm from being buried underwater. The Bahamas, Australia has one. There are 105 countries that actually have an airport below sea level somewhere in their country. That means there's like a dip in the middle of the continent, and there's an airport in that dip. And that dip just happens to be lower than sea level. So if I do this, and I could do it as a subquery, and you'll notice it'll give me the exact same number of rows. So any is the same thing as an in, essentially. However, any does have one cute trick. You can actually use a less than or equal or greater than or equal sign with it. So earlier where I did less than the average, but let's say I don't want to do an average. I want to say I want to know any airport where the elevation is greater than the elevation of a specific airport or a specific country. So in other words, we know if I were 2 should be Canada. Make sure I'm not lying. Hang on. Canada should be 2. I'm just going to go like this. No, 2's Cambodia, not Canada. Okay, so let's go look at any country where the elevation is greater than any of the elevations in Cambodia. So if we run this query, we'll have a series of values. We'll do this. And apparently the elevation in Cambodia is 0, or sea level. Therefore, it's going to tell me anybody who's greater than this. Actually, let's go do country 3 so we actually have something a little more realistic. There we go. So 46, 761, and 194. So if I run this, every one of these airports should have an elevation greater than at least one of those values. Notice it's a little weird because it comes back with 3 values, right? So it's basically returning anything that's greater than 46. You could do the exact same thing by, this one here where I did the average. You could do a min or a max, and it would give you the exact same result. It's multiple ways to do the exact same thing. It just depends what you want to do. Now, mind you, you could use this for business concepts where you're trying to find out which product sold the most or which one sold less, and you can do a query using that range kind of stuff. You could theoretically put it in a between. You want to find out the earliest date and the oldest date, and you want to do a between, you could do subqueries with that. It has a few interesting things. Now, I'll be completely honest. I've been working as a web developer for, well, not anymore, but I was a web developer for close to 25 years before I became a team lead and I just do paperwork. If you want to work with your hands, just don't become a team leader. You don't have to do anything. Um, the I never used any in those years. Now, data scientists probably would use it. Statisticians would do it. People trying to get trends out of business databases would probably use it. I just never used it. So it's good to know they exist as a tool. And sometimes you'll try to come up with some way of doing it. And like I said, if I would have just used where the elevation is greater than, I would have selected the min instead of using any. That's all. All right, so now we get to these have been all easy examples of subqueries. It runs one query, returns the results to the other query, end of story. The complicated kind of subquery is known as a correlated subquery. A correlated subquery, and I'm pretty sure I spelled that right, but apparently not. It's not double R. Apparently it's double R. But when I actually looked it up, it was one R. So that's why I was pretty sure it was right. Okay, so a correlated subquery is when the subquery refers to a value in the outer query. So when you're pulling data from the subquery, it actually pulls it for the values on the outside at the same time. This gives you a lot of power in the sense that you can make sure that the value is always valid. However, it has a really big gotcha. It will run the subquery for every value in the outer query. So with every one up here, the subquery is run once, the results are passed to the second query, so there's two queries being run, right? If you have a correlated subquery and you have 100 rows, you're going to run 101 queries. Because it's going to pull the first query, and for every row, it'll run the subquery. Correlated subqueries are expensive. However, they have some fairly useful things you can do with it. And one of the most useful ones is the exist operator. So you'll notice that this is a really strange looking predicate because so far every predicate we looked at had column, operator, some sort of value, right? You'd have a number or a subquery or a list of values or a string. You'll notice that this one doesn't have anything on that side of the operator. Because what exist does is, so I want to list all the countries, okay, where the country record exists in that query. And you'll notice right here that I'm referring to the countries table on the outside. So when I highlight, you can see it highlights in purple, right? So it shows that this ID is being pulled from here, not from inside the subquery. What this is doing is, I gotta get my wording correct before I keep talking. Essentially, it's going to return a value or a null. If it returns a value, it means that country record exists in this subquery. If it returns a null, it means it wasn't found, so it skips it. So it'll go, country 1, do you exist anywhere in this list of airports? If it returns anything, yes, so it's valid, it's true. If it returns a null, it's not valid, so it only returns, specific values. And yes, I could rewrite this as a join. I'm just saying, it could be written as a join. So I'm going to run this. And so for airports that start with A, apparently there's an airport source in Costa Rica, in Eritrea, in Turkey, in Chad, Cyprus. 101 countries have at least one airport that starts with A. And that's what exist does. So I've actually put in the definition at the top here. So, for you guys to go look at it. So the exist operator is used to test for the existence of any record in a subquery. It returns true if the subquery returns one or more records, and false otherwise. So it's like I said, if it returns anything, it's valid. If it doesn't return anything, then it's invalid and it skips that record. And it goes up and up and up. Exists I have used in my career a few times. It's a very specific purpose type of operator. And it's one of those things where you don't know you need it until you need it. If that makes sense. Like you'll sit there going, man, I can't figure out how to do this. And you go, I wonder if there's a way to check if a record exists. And then, you go look SQL, how to see if a record exists and stuff, then there. It's absolutely not a query you use all the time. But it's a handy one to see, for example, you want to find all the products that are in an order line. You could use this to write it. You can get really fancy and say, hey, find out all the products that have been sold more than once or sold more than 10 times and that way you can actually find out which products actually have sold reasonable amounts. There's all kinds of things you can do with it. Okay, so these are niche subqueries. But what we can do is we can get a little fancier. And one of the things that a lot of SQL profs don't teach, especially when, you have short lectures and they only copy one topic, is they don't talk about the other places you can use subqueries. I remember several times when I was teaching in a different course where I'd received the slides after somebody else had it, and they stripped out everything but using the subquery as part of a where clause. However, you can use it almost anywhere. So I go select a name from airports, okay? And I'm going to go country ID. Great, I got a list of airports and I got a country ID, but I don't know what this country is. What you can do, now, of course, you could do it the proper sane way, right? Which would be do a join and show the name, away you go. But you might want to be that person. And now I am using a correlated subquery in the select part. The name's coming from the countries. Oh yeah, the name is showing as the SQL thing. So at that point, you should be sane and go country name just to be a little more reasonable. So what this is doing is it's saying, hey, give me the airport name, and then it's going to pull the name of the country, but then it uses a correlated subquery to go figure out what the name of the country is based on the ID in the parent table. Like I said, this would be written as a join normally, but this is something you can do. It works. Normally, something like this you would do if you're trying to populate records where you don't know what the values might be. So you're setting up test data, or you're trying to automatically build records based on other stuff in the database. That's when you do something of this nature, which I am about to demonstrate right here. So if I go insert into airports, name, comma, country, ID, and I go select, I don't know, app, airport, comma, select ID from countries where name was equal to Canada. Okay, so I am going to run this to show you what it does. So it's going to return two values, right? So it's going to return cap airport and a number, 208. Apparently Canada is 208, not 2. And then I want to insert into airports, and this is going yellow because I'm probably missing something important. I'm missing XY. Okay, so let's go 100 by 100. Actually, no, so that's X comma Y and ID. So I need to return the ID. So now I don't know what the max ID is in that table right now. So I could do this. And then let's put in some bushel values for X and Y. 100 by 100. Okay. So I'm just going to run this select statement, and you can see that this select statement is not even pulling from a table. People don't realize you can just write a select statement, and if it doesn't actually need any data from a table, you can do it. All right, so I'm going to run this. And apparently the max ID is 942 of 941 because I'm doing give me the max ID plus 1, so I don't conflict on my primary key. And that's another way you can get around sometimes not knowing what values are in a database. If you need to insert something and you need to be bigger than, there's a column with values in it, but you need whatever value you have to be bigger, you can do it like this. And then I'm going to insert it, and let's go see what this looks like. 9542. And here's my record I just inserted. Now what's cool is now I'm going to rerun. I'm not going to do another insert, but I'm going to rerun this. And now the ID is 9543 because we now have 9542. We were using a subquery to calculate the next ID. In database servers that don't have things like sequences or auto increment, it's literally done like this. I've seen people write code where insert language here. I'm going to pick on Python today because you guys are learning Python. Where they write this chunk of code, they go, select max ID from this table. They run the query, return it, add 1. That was a cute sneeze. Add 1, and then try to do the insert. But the problem is that while those steps are happening, somebody else might do the exact same thing. So you might generate a duplicate ID because you're not getting the database server to do the whole thing in one step. This lets you let the database server do all the work in a single step. And now I'm going to delete that record because I don't want to leave my database contaminated. Like that. All right. So these are handy uses of subquery in the select part of the query. Now we can get fancy. So let's say we go select star from, but let's say we want to do some math on our numbers and still work with it. So let's go the count of star. No, let's go select the count of star as airports, comma, country ID. No. Country ID, don't finish it for me. From airports, group by country ID. And I've been working with Oracle for too long. All right. So I just created a query that counts the number of airports and returns the country ID, and it groups it by a country ID. So now we know how many how many airports each country has. It's actually a kind of a useful query. You will notice right here that it says airports here. So this is known as, it has two different names depending on who you talk to. It's known as a virtual table, or the more common name is a derived table. So what this does is it creates a temporary table in memory. And it gives a temporary table a name. That's why you have to have an alias. So it's creating a table only in memory called airport count. This is one of those cases where it looks like a table, it acts like a table, it doesn't actually exist. It's never going to show in the database because it only exists for the lifetime of the query. It never lives on, it never goes to the disk. It stays in RAM the entire time. But what's cool now is, remember when I was talking about aggregates where you can't nest aggregates, you can't aggregate an aggregate because the aggregates only ever happen once? Now we can go the average airports. So apparently there's 33.7792 airports on average in every country. So you can use a subquery in the from clause. I'll be posting this file. Because every class I have students that take pictures of the screen, I'm like, I post the file. It'll be up by tonight, probably by like 7:30. And then you can take it and run it yourself. So this is where you can aggregate an aggregate. You can do nifty things with this because you could do a join, you could do a bunch of other things if you wanted. What's really cool though about this is I'm going to take the aggregate off. I'm going to go select star. I can actually go join countries on countries.id is equal to airport count country ID. Okay, and now I want to go comma. Now I'm going to, no, don't do that. I'm going to go airport count dot airports comma countries dot name. And now I've got a name and the average and the count. Again, right now I don't need a subquery to do this. I could just do it as a normal whatever. But imagine that this internal query is more complicated where we're doing some transforms, maybe we're doing additional math, stuff that wouldn't normally be easy to do. You can just create a temporary derived table to do the math for you. Now, what we could do is we want to go the average like this. And we want to go, oh boy, what's the function? Hang on. I'm making this up as I go. So MySQL left character. I can't remember if they have a left operator or if it's it's a left. Okay, good. So I go left, comma 1. And I go group by. Let's see if I guessed the syntax correctly. Okay, so this is a totally useless query, by the way. It has absolutely no meaning, but it demonstrates a bunch of different techniques all in one. So I'm getting the average count of airports. I want them grouped by the first letter of the country. So all countries that start with C, there's an average of 44 airports. Countries that start with E, there's an average of 14 and a quarter. Apparently L only has 6.5, and W has 1 3/4 airports on average. It's not a useful query, but it's a cute trick. And it shows you the power of being able to use derived tables and or subqueries because you can create data sets that normally you wouldn't be able to pull. Some people don't like using derived tables. They'll create a view. But what happens if this is just a one-off? You only need to do this once. Why would you take the time to create a view, run this one query, and then delete the view? It's not particularly useful. So this is a really good use for a subquery. All right, now the other thing is you can nest subqueries. The good news is database servers have gotten significantly better and more efficient. Computers have gotten much, much more efficient and much more powerful. I mean, okay, except for the Mac users, does anybody in here have a computer with less than 16 gigs of RAM? Mac, you only need 8, because that's what Apple says you need. So this is a nested subquery. It'll run each query, they'll run the inside query, pass the results to the next query, the pass the results to the next query. When I first taught a database course at the college, and like a purely database course, not just something that was mixed, I had to demonstrate nested subqueries, and I went a little crazy. And my laptop blue screened because it ran out of RAM. That would have been 2008. Okay, so just probably before some of you were, or close to when you guys were born, right? So the computers back then, my laptop had 4 gigs of RAM. And it was actually more powerful than half the students' laptops. So some people only had laptops with 2 gigs of RAM, some people had laptops with 1 gig of RAM. And I ran a nested subquery and it blue screened because it ran out of RAM. You literally heard the fan turn on. It ran for about 30 seconds and then just said, your screen turned off. No. I picked up my laptop and blue screen of death. The old-fashioned style blue screen of death. So I'll run this and you'll see it's like instant. Once upon a time, they wouldn't have been instant. So this just to show that, yeah, you can nest multiple subqueries. There's times you want to do something like this. This is not it. This is a demonstration of, yeah, you can nest. But there's a cost. Let me go see if I can explain this, do the explain on this. Parameters. Explain. That explains an interesting thing. It's not something they teach. Usually you learn this at higher levels. Explain shows how the database server thinks it's going to solve the query. So you can see that it nested loop, does a filter, does an index scan, does the unique scan, and then it returns the results. So because it has to run this one first, then it runs this one, and then it's able to do the rest from there. So it's just showing you that there's things it has to do first. And I have one last example of exists. So if you guys are actually reading the slides, this example's in the slides. And this is an exists example where we have, we want to know the city and the country code for any city with a population of more than, a country with a population of more than, that's 1,000, 1.1 billion apparently. So any country, we want to know the name of the city for any country that has a population of more than 1.1 billion. Which realistically, if we scroll through this, eventually we'll have China. Or 11 billion, actually. Old database. Other countries have caught up. Just say. So yeah, this is another use of an exists. So you have another example in the file. So that's it about subqueries. It's actually not a super long topic. It's just you have to learn how to play with it, and these examples will, give you some of pretty much everything. In actual fact, I'm kind of curious about that. If I switch this back to FlightDB, that fancy one I did with the everything in it, this one here? I'm just curious what the explain will do. full scan, temporary table, loop, table scan, index, materializing the view, as in other words, making it exist. Then it does an aggregate, then there's a group aggregate, then it does an index scan. It's that query is not very long, but it makes the database server work really hard. Which is really cool when you think about it, that it ran in how quickly did that run? What was that? In this, the total cost, um, uh, it's how expensive that task is. I don't remember what this number exactly is, but the bigger the number, the more expensive that piece of the query is. So if we do, let's go grab this one here and do the explain on it. Okay, the problem is that different database servers represent the explain differently. If this was Postgres, I could tell you exactly what that number means. I just don't, I work so rarely with MySQL. Like you can see that the total cost is whatever this number is up here. And then these are the components, and some of this is a nested loop. So the loop was this expensive, and then each of the subpieces cost that much. You can see these ones here all cost the same thing. Let's go take a look at this exists and see how expensive it is. Explain. And apparently that one does. Oh, okay, so let's go run it. Okay, now let's go explain it. And again, you'll have these, the filters all cost the same. The nested query takes the most, like it takes 22,000 points, let's call it. If we just look at the internal query and explain that piece, I can't because it's a correlated subquery. It needs the outside piece to work. Let's take a look at this one and see how expensive this one is. This one was very quick and not expensive. You can see there's a subquery select with a unique table scan. It's running on things that are indexed. Therefore, it loaded the index in memory, and after that, it knew the answers instantly. Actually, I was really surprised how quick that ran, how short the analyze is on this. And there's the other analyze too, which is the explain. Cost this many rows, actual time, one loop. You know, that's the verbose version of that. So yeah, that's subqueries. This file will give you one of everything you need for the lab, just so you know. Although the lab is not against the flight DB, every technique you need for the lab is in this one file. And like I said, it'll be posted tonight, so you'll have an executable version of this. All right. I have just one little announcement before I stop the record. By now, you guys should know what your final exam schedule is. And I actually looked at it before I came to class, and I forgot it already. Hang on, let me go double check it. The easiest way for to look at it is to look at my timetable because I get the exam schedule at the bottom, just like you guys do. So you guys are, it's August 13th at 4 o'clock. August 13th is a Wednesday at 4 o'clock. And then I run away from you guys to go do the other exam literally 2 hours later. I'm doing back-to-back exams just like the midterms. And it's an A1304. If you don't know where that is, have you guys seen the room finding maps? So I'll go, just hang on, this doesn't need to go on the recording.